Hi everyone, myself Dr. K.S.Rangasamy, Professor and Head, Department of Mathematics, K.S.Rangasamy College of Technology. In this video lecturing, let us see the course numerical methods. In the numerical methods, let us see how to find the solution of equations. Equations are two types. They are said to be algebraic equation and transcendental equation. What do you mean by algebraic equation? Algebraic equation is an equation which consists of variables x, y, z like that. And transcendental equations are nothing but having logarithm, sine, cos like that and exponential. To solve this algebraic and transcendental equation, so many methods are available. Among that methods, let us see how to find the solution of the algebraic equation and transcendental equation by using Newton-Raphson method and false position method. In Newton-Raphson method, we can find the solution of an equation which is nearer to 0 or which is away from 0 also. Now let us explain. Let us see how to find a solution of an equation by using Newton-Raphson method. The general formula, iterative formula which is used in Newton-Raphson method is xn plus 1 equal to xn minus f of xn by f dash of xn. This is the iterative formula which can be used in Newton-Raphson method to find the solution of an algebraic equation, or it may be a transcendental equation. Now let us elaborate this method by using an example. Let us see the equation 3x minus cos x equal to 1. I am going to find the solution of this transcendental equation by using Newton-Raphson method. Why I am saying it is a transcendental equation is it has the cos function, so I can say it is a transcendental equation. The first thing I have to write it as f of x equal to, I have to take this given equation as f of x equal to 3x minus cos x minus 1. Now I am going to find where the root lies for this equation. So I can substitute x equal to 0 and x equal to 1 like that until the two values have opposite signs. When I substitute x equal to 0, this becomes 3 into 0 minus cos 0 minus 1. Therefore the value is minus 2. When I substitute x equal to 1, I will get that value 1.460. Now we can come to the conclusion that there may be a root of this equation which lies between 0 and 1. Since it has opposite sign, we can say that the root lies between 0 and 1. It crosses that axis, so we can say the root lies between 0 and 1. Since the root lies between 0 and 1, I can take that midpoint as x naught as a plus b by 2. Here a is 0 and b is 1. So I can write the midpoint as 0.5. When I calculated x naught, I can go for the first approximation as x1 equal to x naught minus f of x naught by f dash of x naught. Since the general iterative formula is xn plus 1 equal to xn minus f of xn by f dash of x naught, I can go for first approximation. When I do for first approximation, I can replace n as 0. So I can get x1 as x naught minus f of x naught by f dash of x naught. Since I have the x naught value as 0.5, and with the help of 0.5, I can calculate f of 0.5 and f dash of 0.5. F of 0.5 is nothing but the given equation. Once again, This is the f of x 3x minus cos x minus 1. From this equation I can replace x value as 0.5. I can get the value, and for this equation I can find the derivative also, f dash equal to the 3x and differentiation of cos x, that becomes sin x, then this becomes 0. So with the help of this differentiation I can have these values f dash f of x naught and f dash of x naught. So I can get the value of as x1 as 0.609. With the help of x1 first approximation, I can go for second approximation as x2. Similarly, with the help of x1, I can calculate x2 as x1 minus f of x1 by f dash of x1. Wherever in the equation x, I replace x1 value. In the equation of f dash, I can replace x1 value. So I can get 0.607. So in the same manner, I can continue the steps until the successive approximation have the same value. Since in this problem, second approximation and third approximation have the same value, I can stop the process and the solution can be taken as 0.607. This is the solution of the given equation. Therefore, this is the easiest method to find a solution of the algebraic and transcendental equation. This is a root which lies nearer to the 0. Now this is, we can take it as a practice. Once again, this equation x log x equal to 12.34 something. This is nothing but once again it is a transcendental equation. Now this equation you can say it is an algebraic equation. Now it is a cubic equation, x cube equals 6x minus 4. You may have the idea it has 3 roots, but in Newton-Raphson method we can find at least one root of the given equation which is nearer to 0 also. So we can find the solution by doing practice. Now, as you did in Newton-Raphson method, we can see another method, false question method. The same set of equations, that is either it is algebraic or transcendental, we can use another method, false question method, to find the solution of the equation. In false question method, the iterative formula is xn equal to a into f of b minus b into f of a by f of b minus f of a. A is nothing but the lower limit and b is nothing but the upper limit of the values which we obtained from the given equation. Always a is lower limit and b is upper limit. Let us see with an example. Let us take the example x cube minus 5x plus 1. I am going to find the root of this equation by using regular falsy method. Now, once again, I have to substitute, take it as f of x is x cube minus 5x plus 1. I can replace x as 0, so I get the value f of 0 is 1. When I substitute x equal to 1, I can get the value as minus 3. Since these two values are in opposite sign, we can conclude that the root lies between one root, among these three roots, one root maybe lies between 0 and 1. Now we are aiming to find that root. Since the lower limit is 0 and upper limit is 1, I can take a value is 0 and b value is 1. Now I can make use of this tabular column. This is approximation, this is a value and b value, and these are all f of a value and f of b value, and this is iterative formula. Now I am going to make it as a as 0 and b as 1. I am going to find f of 0 and I am going to find f of 1. Then after getting all these values, I can substitute in this iterative formula. When I calculate it, I will get that x1 first approximation as 0.25. Now with this x1 value, I can replace this x1 into given f of x. Now I have to recheck this f of x with the previous f of a or f of b. Now this is, since it is negative, I have to recheck with f of a and f of b which is having positive value. Since f of a has the positive value, now I take the lower limit as a as 0 and upper limit as this 0.25, since these two things are having opposite sign. So a is 0 and b is 0.25. We are coming closer to the root. So once again f of a is remains as it is 1 and f of b is nothing but our value minus 0.234. That thing I have to take into consideration. Then I have to make this as a and b. I have to calculate x2, therefore it becomes 0.203. So when I get the value of second approximation, I have to substitute in the given equation. I may get that f of x as minus 0.007. When now we see these values are reducing, so we can come to the conclusion we are closer to the root. We are closer to the root. Now since it is once again negative, I have to compare with the positive. Once again I have to compare with f of a. So a remains, lower bound remains as it is 0 and upper bound is remains 0.203. So f of lower limit, then f of upper limit. Once again, I am going to find third approximation x3. It is 0.202 and the f of x value is nothing but very closer to 0. Once again, I have to compare this negative value with positive. Once again, it is nothing but f of a remains as it is. So a is lower bound and b is 0.202 and f of a and f of b. Once again, I substitute in that iterative formula. So I may get that value as same. x3 and x4 are similar and this is also similar. Since both approximations have the same value, we can stop the process and we can say the solution of the given equation is 0.202 for the given equation. Like this, we can find the solution of an equation by using false position method. Thank you.